Today's paper is going to be another one on COVID wastewater underestimation using current techniques. And this is going to be our third paper in this series, and it's from three different groups. So when you're having three distinct groups come up with the same essentially findings, this is a good indication that yes, these findings are true and hold consistent. Now, this is a paper out of Ontario, Canada that looked at the provincial wastewater system. It looked at the copies of N1 protein and N2 protein, essentially just the nucleocapsid protein in two different regions. And then they also looked at pepper-mild model virus, so similar to how Wastewater Scan does it. This study looked at data from November of 2021 to January 31st of 2023, so it has multiple years worth of data. And what they found is that there was a loss of sensitivity in the nucleocapsid 1 assay in this period from July 10th, 2022 to January 31st, 2023, where this loss of sensitivity is due to a high proportion of mutations in these specific regions. So why would these specific regions matter? Well, it's the regions where the probes actually bind to the nucleocapsid protein. So that's how they detect it. You have primers that will go and adhere to very specific sections of the genome, and once it does that, it can be tagged and turned fluorescent, and you can label it and therefore measure the signal of the fluorescence and then get a concentration. Therefore, if you think about this as like a slotted key in a lock, so you have a bunch of ridges on your key, you have a bunch of ridges on your lock. If some of those ridges are mismatched, it's not always going to snap into place and adhere. This is what inefficient annealing is. It's essentially an inefficient way of binding. It's not always binding correctly or appropriately. So if these primers don't bind appropriately, this will result in a reduction in the sensitivity and accuracy of the signal that's produced, meaning that you're going to get an underestimation of what it is because you're not getting as efficient a binding, you're not getting an accurate binding, so you're not getting an accurate count of how much COVID is in that wastewater sample. And you might be thinking, well, why does this even matter? It's just Canada's wastewater system. Well, if we look at the data, we see that nearly 4,500 locations across the world use the same technique and methodology for testing COVID in wastewater, which means that it's a widespread problem. Even in the United States, it's a very widespread problem. Because if all of these facilities are using a flawed technique, which is resulting in an underestimation of COVID in the wastewater, it's going to look like things are decreasing in signal intensity over time, but they're actually not. They're just not being measured appropriately. Where much of this problem is coming from the fact that there exists a lack of guidelines on the standard collection practices and processing practices for COVID in the wastewater. We've discussed this before with the US, how in some places they're doing these microbial methods, in other places they're doing flow calculations, in other places they're run by like wastewater scans, some have historic biobot analytics processing techniques. It's all a hodgepodge of data collection methods, data processing methods. Nothing is standardized, and that's why they have to do that NWSS COVID viral activity wastewater calculation. It's because they're compensating for the fact that each site does something different, and they're not willing to put in the effort to be like, all right, everyone needs to do this the same way, and we're collecting the data in the same way, and we're processing it in the same way at this same types of facilities, and we're going to have our quality control to make sure that everyone's doing it correctly, everyone's collecting samples the same way, everyone's processing the samples the same way, everyone's using the same kits to run their assays, and that's something that isn't done. Everything's sort of like privatized all over the place, so you have all these disparate guidelines and disparate practices, and that's what's driving a lot of this issue. Now, in this paper, to try and address this, they're measuring both the N1 and N2 concentrations in the wastewater. They're taking this from all the sites in Canada, and they're developing what they're calling the quality assurance, quality control ratio calculation. So basically, they're seeing the proportion of N1 and N2 in the wastewater. They're creating sort of a ratio adjustment for this, and then they're using that adjustment to back correct retrospectively to try and fix the wastewater signal. That's what they're trying to do. I don't really agree with this methodology. I think it's sort of short-sighted because we assumed from the very beginning, oh, well, the reason why we're going to pick this nucleocapsid protein is because there's very few mutations compared to the spike protein. And then after 5 years, we're seeing that, oh no, the N1 protein, the nucleocapsid protein in the N1 loci, the N1 region for binding, is going to have all these mutations. The N2 seems more stable at this point, but that doesn't mean it's going to be stable forever. So I think that there could be a scenario, and they mentioned this in the limitation section of this paper, where you have mutations in both the N1 N2 ratio. So you're having uniform decreases in both, but since they're the same ratio, even though they're both lower, it makes it look like the signal's fine. So I don't think this is a good method because it's taking a big leap in assumptions, saying, N2 is not going to change. It's really just the N1 that's going to garner these mutations. And I think that's very short-sighted. I've seen other papers. We reviewed one other paper that had a much better technique to compensate for this. But this is just something they did in this paper. We're going to look through it. We're going to listen to it because more it's the process of showing that everything is being underestimated right now than it is their potential solution. So to give you a pictorial representation of what that lock and key metaphor analogy that I was talking about earlier is, so right here, this red boxed C would be an example of where that like a point mutation would be. So you can think of this as like an extra ridge or groove in the key slot. So if the key is trying to lock into place, then it would kind of like be like lifted up a little bit. And the more of these you get, the harder it's going to be for that key to actually like lock into place. Even though everything else is matching, you're going to start having these mismatches that really ruin the binding for everything. And that's going to result in weaker fluorescence, weaker signals, and therefore lower measured concentration. So you have like a true concentration value and a measured concentration value. Ideally, they're the same. But when you have issues like this, that's going to lower the measured value from the true value. And that's exactly the problem we're seeing. So if we have before Omicron right here, which is what the primers were more originally designed for. So you have before Omicron, which is like XBB. This is defined as April 8th, 2020 to November 28th, 2021. And we're seeing that there's very good match. There's the measured value and the true value are essentially the same. Then we have early Omicron with the emergence of XBB, and we're seeing that the measured value is becoming lower than the true value, and this is statistically significant. And then we have late Omicron, where we have it going down even more. So the measured value is getting even lower from the true value. So what I mean between measured and true value? So the measured value is what you're getting from your signal testing. So if we say there's a pile of marbles and the true value is 500 marbles, but we go and count it, and maybe we have like a little bit of blindness in our left eye, so we're missing marbles. So every time we do the count, we're counting, there's 400 marbles. Well, the measured value is consistent, saying, it's always 400, but there's an issue. I'm blind in my left eye. So the true value is actually 500. That's the difference between a measured value and a true value. Even though my measured value is being consistent and always coming up as 400, there's an issue systemically that is making it so that I'm not getting the 500, which is the actual value. Where the core of this problem is this line right here. So basically all COVID-19 diagnostic targets have undergone mutations because COVID has continued to mutate over time. And the N gene targeted by the most commonly used primer probe assays for diagnosing COVID-19, it exhibits some of the highest rates of mutations across the viral genome outside of the spike protein. So because this has continued to mutate, it's resulted in signal degradation, which means that our measured values are going to be an underestimation of what the actual prevalence of COVID is out in the wastewater. And as we've covered at least 2 other times now, this is not the only paper that has shown this result. And despite these concerns for the worldwide implementation of the wastewater surveillance system for COVID-19, there's no adjustment criterion. There's no method that's been universally developed and applied to retrospectively make these corrections to have the wastewater signal, the degradation in the signal, be back corrected so that it's actually showing the true signal. We're just accepting these results saying like, look, COVID wastewater is going down consistently over time. And it's like, no, we're actually getting signal degradation, which is giving us an artificial sense of security, thinking that COVID is going down, which means that we're not seeing the spread in communities that we think we're seeing. There's actually more COVID out there than we think there is because we're putting all this reliance on the wastewater surveillance system without routinely updating and routinely monitoring and making sure that errors like this aren't getting back corrected. It's bad.